Periodic movements such as the rise and fall of tides, the height of a pendulum over time, the variation of a point on a bicycle wheel as it moves forward, and other similar real-life scenarios are frequently observed. The sinusoidal function is frequently applied to these cases. In most cases, when creating a sinusoidal function from given values like maximum and minimum points as well as the period, several key elements need to be determined. 1. Amplitude. This is half the difference between the maximum and minimum values. 2. Vertical shift. It's half the sum of the maximum and minimum values. 3. Horizontal dilation. Horizontal dilation is influenced by the coefficient b of the x term, where b is obtained by dividing 2 pi by the period p. Let's consider an example to understand how to create a sinusoidal function. Imagine a Ferris wheel in an amusement park with a diameter of 70 feet. Passengers board at a height of 5 feet above the ground, and the Ferris wheel completes one rotation every 40 seconds, always starting its operation at 0 second. Step 1. Examine the given conditions and obtain necessary information. Period of the Ferris wheel, p, equals 40, horizontal shift, h, equals 0. The minimum height of the Ferris wheel is 5 feet, and the maximum is the sum of the minimum height and the diameter, which is 75 feet. So, maximum m equals 75, minimum m equals 5. Step 2. Calculate the amplitude, vertical shift, and horizontal dilation. Amplitude, a, equals 75 minus 5, over 2 equals 35. Vertical shift, k, equals 75 plus 5, over 2 equals 40. And b equals 2 pi, over 40 equals pi over 20. Step 3. Based on the type of sinusoidal function that begins from the minimum value, which is y equals negative a times cosine, b, x minus h, plus k, substituting the values. Y equals negative 35 cosine, pi over 20, x, plus 40. Alright, here's the problem. The first question. After the Ferris wheel begins to rotate, when is the first moment it reaches a height of 50 feet? To find the time when the Ferris wheel reaches a height of 50 feet, you substitute 50 for the y value in the given sine function and solve for x. Subtract constant terms and divide each side by negative 35. Then you get pi over 20, x equals cosine inverse of 10 over negative 35, which results in 1.86. Therefore, the value of x is approximately 11.84 seconds after the rotation begins. The second question. How much distance did this Ferris wheel cover between 18 seconds and 22 seconds? Now, to determine the distance did this Ferris wheel cover 18 seconds and 22 seconds, observe that it covers 4 seconds out of a total period of 40 seconds. This represents 1/10 of the full cycle. The total circumference of the wheel is c equals 2 pi r equals 70 pi feet. Thus, the distance covered in 4 seconds is 70 pi times 1/10, equals 7 pi feet. Therefore, the Ferris wheel covers an arc length of 7 pi feet during this time. See you next time.